Hi, guys. Welcome to our mini lesson on Coulombic attraction and electron shielding. Let's get started. So, first things first, Coulombic attraction. It's a big fancy word, sounds intimidating. It's not. All it means is the attraction between oppositely charged particles, like protons, which live in the nucleus, and then electrons, which live outside of the nucleus. Okay, so here's just a simple picture, and it also shows that like charges repel, which would be Coulombic repulsion, but we're going to keep moving. So let's go more in depth into Coulombic attraction. So let's look at how Coulombic attraction is affected as you go across the periodic table. So when you're going across the periodic table, you're right here. I have three different atoms. They're all in period 3. They all have the same number of energy levels. So first we have sodium, which has 11 protons and 11 electrons. And you'll notice that this has the smallest arrow, and it has the force between our valence electrons, which are way out here, and our nucleus is the least. And then as we move over to aluminum, you'll notice that our arrow is gotten a little bigger, and it has 13 protons and 13 electrons. And then our biggest arrow is over here with chlorine. And so chlorine has the strongest Coulombic attraction between our valence electrons and our nucleus. And the reason for that is because as you increase the number of protons, you increase the attraction between the protons and the electrons. So now we're going to move on to something called electron shielding, or otherwise known as shielding or the shielding effect. So basically what this is it's the blocking of valence electron attraction, Coulombic attraction, due to the presence of inner shell electrons. So let's look at this picture, and it's really good at explaining what the shielding effect is. So we have these outer electrons, and of course they're attracted to the nucleus. However, these inner electrons are repelling them because, as we talked about earlier, likes don't like each other. So both of these are negative, so they don't like each other. So these inner electrons are repulsing the outer electrons, which means that the attraction to the nucleus is less because these guys are cock blocking. They're like, nah, it's our nucleus. And so they're stopping the attraction for the outer electrons. So let's look at how this relates to the periodic table. So over here, we have three elements again, and they're all in group 1. And we have lithium, sodium, and potassium. So lithium has 2 energy levels, sodium has 3 energy levels, and potassium has 4 energy levels. And as you can see, our force of attraction, our Coulombic attraction, the attraction of our valence electrons to our nucleus, is decreases as you get more electrons. And there's 2 reasons for this. The first one is what we just talked about, which was electron shielding. So for lithium, there's only 2 electrons between our valence electron and our nucleus. Whereas with sodium, there's 10 electrons between our valence electron and our nucleus. And then potassium, there's 18 electrons in between. So basically all these electrons, they're blocking the attraction between our outermost electron and our nucleus. And then we have the simple fact that as you add more energy levels, the valence electrons are just further away. So they're not as attracted. It's kind of the same thing. Think of a magnet. So if you have a magnet and you pull the magnet apart, they're less and less attracted to each other the further away that they get. And that's the same thing with protons and electrons. The further apart they are, the less attraction there is. So, quick lesson. Let's just do a quick rehab. recap. Coulombic attraction is the attraction between oppositely charged particles. So think protons and electrons, nucleus, valence electrons. And then we have electron shielding, which is just the fact that the inner electrons block the attraction of our valence electrons to our nucleus. Okay, guys, I hope this was a quick review or overview of electron shielding and Coulombic attraction. See you next time.